The question for this video is, why does x squared equal 9 have two solutions, but square root of x equal 9 only has one? The reason I came up with this question is the way you solve these two sort of look similar. So since we want to get our x here by itself, in algebra they would tell you to do the opposite of this exponent 2. So the opposite of exponent 2 is square root. So I could square root both sides. And on this side, it'd be x. And they end up telling you that this answer ends up being x equal positive square root of 9 or x equals negative square root of 9, i.e. the answer is x equal 3 or x equal negative square root of 9 is negative 3. But then when we do it over here, it doesn't give me two answers. So we want to get our x by itself. So they would tell you to do the opposite of square root. They tell you to do, and the opposite of square root is squared. So then I square both sides. Your algebra teacher tells you that this squared and the square root are inverses or opposites, so they cancel. And so all you have is x here, and then that is 81. So these are the correct answers. But why is it that this one, x squared equal 9, has two answers? The square root of x equals 9 only has one answer. So the rest of the video will be used to explain that. One way I can explain this is using a graph. So here is the graph for f of x equals x squared. Now, in our question we were doing earlier, it said 9 equals x squared. Or technically I wrote x squared equals 9. All right? Well, if this is the graph of f of x equals 9, then to go from here to here, all I really did was change this f of x to a 9. And f of x is like your y value. This f of x is like your y value. So where on this graph is y equal to 9? I know there's one spot right here, and the coordinates there are 3, 9. And I know there's one spot over here. That coordinate is negative 3, 9. So these two spots is where your y is 9. And when your y is 9, my x is 3, or my x is negative 3. That's one way to think about it. Using that same sort of thought process, if I go down to this picture, this is my graph where f of x is equal to square root of x. In the question I did before, I asked you square root of x is equal to 9. And so once again, if this is the graph for f of x equals square root of x, all I did to go between these two is I changed the f of x to a 9. And f of x, once again, is like a y. I know way over here, there's the coordinate 81, comma 9. And so this is where my y is equal to 9. And where my y is equal to 9, my x is equal to 81. That's why the answer for this question right here is x equal 81. Because that is the x value for when my y is 9. Another way you could think of this. So to go from here to here, all I did is I had my f of x equal 9. That's what I did to go from here to here. So if I graphed this right here, f of x equals 9, if I graphed the equation y equals 9, that would be a line that looks like that. It'd be a horizontal line. This horizontal line at y equals 9 touches it right here. It touches my f of x equal square root of x one time. And so where it touches it, that is my solution to these two. So where those two meet is my solution. Versus over here, using the same reasoning I just did with that line, to go from here to here, what I did is I changed my f of x into 9, or y equals 9. Once again, that is just a horizontal line. A horizontal line at the y equals 9. It touches it in two spots. Those are the two spots where my equation f of x equals x squared in blue and my equation f of x equals 9 in green. Those two spots where they touch, my green and my blue, are my two solutions.